Very good. So we learned what method help us to collect the data in the most unbiased way. Now, after collecting the information, we are interested in visualizing the data that we have, right? This is our goal. How to visualize the data that we have. Today we're going to talk about histogram. Okay. When you have numerical data, and if you have finite numbers of them, we prefer to use paper and pencil to visualize this data set using a histogram. Okay. Numerical data or quantitative data. Using a histogram to visualize them. So before talking about the histogram, first of all, when you have a collection of data, you need to put these in a nice and compact table. So from a collection of data, first we're going to put this in a frequency table. Frequency table. Okay, what is a frequency table? After using the frequency table to arrange the information that you have, write them in compact and nice table, then you're going to use a histogram to visualize the data. So I'm going to talk about the frequency table through an example. So let me share the example with you, and then we're going to build a frequency table together. I have an example here. Well, this example says, constructing a frequency distribution from a data set. The data set lists the prices in dollars of 30 portable global positioning system or GPS navigators. Question says, construct a frequency distribution that has 7 classes. So we have $128, we have $100, we have $65, we have $150, we have $90, $340, and so on. Our goal is to take this information and then put them in a nice table that we're going to call a frequency table. Very good. So let us go over the steps of building a frequency table. For GPS prices. So in constructing your frequency table, first you have to identify the beans or classes. The question says you're going to use 7 classes. So we already know we have 7 classes. So let us start forming the frequency table. Frequency table. Well, this table has rows, it has columns. On the very first column, you're going to have your beans. beans or classes. Okay. So let us learn how to construct the beans. What are you going to do? You're going to find the smallest number in your collection. The smallest number in your collection is the starting number. So what is the smallest number in the collection? The smallest number in your collection is so the smallest number in our collection is 65. You're going to write down 65 as the starting number, 65. And you're going to put a dash, okay. Later, we're going to decide on the number that the class or beans going to stop or the upper limit. Now, what are you going to find? You're going to find the class width. Class width. Class width is maximum value minus minimum value divided by the number of classes. So what's the maximum value in your collection? We already know that the minimum value in the collection is 65. What is the maximum value in the collection? And what is the number of classes? The number of classes is given to us as 7. So I'm going to copy this down here. I'm going to use a different color so you know. It's already given to me. I'm just copying this guy down here. I need to know what is the maximum value. $340 is the maximum value in our collection. 340 minus 65 divided by 7. Guys, again, 7 is given in the question to me. The question says, I want you to have a frequency table with 7 classes, 7 rows. So I'm going to do the division. If you do the division, it's going to give you an approximation. What is that? So approximately we have 39.3. We're going to round it up. Round up, it's going to be 40. So, important observation. When it comes to class width, always round up. It doesn't matter if it's 39.1, 39.2, 39.3, 39.4, you always round up. Round up. Okay, so I have 40 as the class width. What I'm going to do, I'm going to add 40 to 65. Add 40 to 65. My lower limit is 65. Now I'm going to add 40 to it. Plus 40. And I get the next class lower limit, 105. Okay. So 65, it's the lower limit of the first class. 105 is the lower limit for the second class. I'm going to do the same process. 105 plus 40. 145. 145. Then I'm going to add 40. And I keep repeating this step. So far I have 1, 2, 3, now 4 classes, 185, add 40. 225, add 40 to 65, to 65, and the last class plus 40, 305. Okay, and this is my last class. All of these are 305. Our lower limit of each classes. Okay, now take a look at this. My first class starts at 65 and it has to stop at a point, at a number which is different from the second class. So it starts at 65 and we have to stop at 104. 104. You can do the same steps, adding 40, 144, adding 40, 184, and adding 40, well, to 24, adding 40 and to 64, adding 40, 304, and 344. I have 1, 2, 3, 4, 5, 6, 7 classes. 7 classes. Okay, cool. The very first step, creating the beans, done. The next step is finding the frequency, the count in each class. Frequency or the counts. Now you need to take a look at your collection. 65, how many 65 do you have? How many 66 do you have? How many 67 do you have? How many 68 do you have? How many 69 do you have? How many 70 do you have? And find all of those numbers and include 104, and it's going to be count or frequency of the first class. So for the first class, it's 65, 104, so 101, and then you have 92, then you have 85, 3, then you have 65, 4, then you have, let's look for, okay, 5, and then you have 6. So the frequency of the first class is 6. If you continue this process, the frequency or the count is 6. And find the frequency of the next class. By doing the same process, the frequency of the second class, C, is going to be 9. The frequency of the third class is going to be 6. The frequency of this class is 4. Then the frequency of the next class is 2. And then you have 1 and 2. Very good. So we found the frequency or count for each class. Next, you're going to find representative for each class, which is the midpoint. Midpoint or representative for each class. So to find a midpoint for your class, you're going to take the lower limit of each class, add it to the upper limit of that class, and divide it by 2. Basically finding the midpoint. Midpoint or the representative. So you take the lower limit plus the upper limit of the same class. Guys, you cannot jump into different classes and take the lower limit and upper limit and then add them together. For each class, the midpoint or the representative of that class can be found by adding the lower limit and upper limit and divide it by 2, finding the average. So for the first class, you're going to add 65 and 104 divided by 2. The second class, 105 to 144 divided by 2. Third class, 145 plus 184 divided by 2. Then add 185 and 224 divided by 2. It gives you the midpoint, the middle point in between them. 225 plus 264 divided by 2. 265 plus 304 divided by 2, and 305 plus 344 divided by 2. Why we need midpoints? Sometimes as a statistician, you are working with confidential data. Your numbers, your actual data, for example, the prices that you had there are for sensitive, for example, devices. You cannot release those information, or they are not in the market yet and they are in competitive mode. You are not allowed to release those data to the public. What you can do instead, you can say that, hey, I'm going to use a representative for each class, for each category by finding the midpoint for those collections. So the representative for this class is going to be a number in between these two. So you expect a number between 65 to 104. If you have a number which is less than 65 or larger than 104, it means that you made a mistake somewhere. So it's going to be 84.5, 84.5. Now, what I can do, I can just add 40 to each one of these numbers, the same process, plus 40, plus 40, and continue this process. Okay. 124.5, 164.5, 204.5, 244.5, and 284.5, and this was 265. And this guy is 324.5. We found a representative for each of these classes. Very well. The next thing that we're going to find is relative frequency. Okay. The formula for relative frequency is doing the division. You're going to take the frequency of each class and divide it by the sum of all frequencies. So relative frequency, let me write down the formula on top here for you. Relative to the rest of these classes, what is the frequency? Relative frequency or R sub F is equal to, you're going to take the frequency of each class and divide it by the sum of all frequencies. So if I take all of these frequencies, add them together, it's going to be equal to 30. The sum of all frequencies is denoted by sigma sigma f. So you're going to take the frequency of each class and divide it by the sum of all frequencies. This symbol is called sigma, representing the addition. So this is sigma. It means you have addition. Okay, the sum of all frequencies is going to be 30, which is equal to the number of data in your collection. So 30, the sum of all frequencies, and you're going to find the relative frequency for each one of these. So the first class is 6 divided by 30. Either use percent or decimal. The second class, 9 divided by 30. The third class, 6 divided by 30. Then you have 4 divided by 30. Then you have 2 divided by 30. 1 over 30. And finally, 2 over 30. Relative frequency. Very good. So here you have 20%, then you have 30%, then you're going to have another 20%. It's going to be the same as before. And let's see, you're going to have 13%. Well, the next one is going to be 7%. Then you have 3% and another 7%. We can use a relative frequency to form, for example, your pie chart. Each one of these percentages shows the percentage for each of those pie slices. Okay, after finding the relative frequency, you're going to construct your cumulative frequency. Cumulative frequency is not very hard to calculate. You're just going to add consecutive frequencies for classes to construct the cumulative frequency. Okay, very good. The cumulative frequency for the first class is just 6. You're going to copy it down. Then the cumulative frequency for the second class is the sum of 6 and 9. 6 plus 9 or 15. The cumulative frequency for the third class is 6 plus 9 plus 6 or 15 plus 6, 21. The cumulative frequency for the fourth class is 21 plus 4 or 25. The cumulative frequency for this class is 25 plus 2, 27. Then you have 27 plus 1, 28, and 28 plus 2, which is equal to 30. It must be equal to the sum of all frequencies or the number of data in your collection. So very well, now that we graph this table, organize the data you're interested in visualizing using a histogram. So what I'm going to do, I'm going to erase some of these columns. I don't need all of them. So I'm going to erase cumulative frequency, Well, I would like to have these stay on the graph so I can show you why we calculate, for example, the midpoint. Okay. Take a look at this. I'm going to construct the relative histogram and frequency histogram. So for frequency histogram, just pay attention here. On the horizontal line, you're going to have your classes or beams. And on the vertical line, you're going to have the frequency. So I have a horizontal line and I have a vertical line. So, well, you can say that my class starts at 65, then it stops at 104. Guys, pay attention a little bit here. So this is my 65, and then it stops at 104. Am I right? And on the vertical line, the maximum number is 9. So let's put this as frequency 10. Then you have 5. It says the very first class, 65 to 104, has a height 6. So it means that you're going to use one box, one bar, with a height or frequency 6, which is going to be roughly here. Okay. Not a nice bar, just a little bit tilted, but that's fine. This is your bar with frequency 6. I'm going to tell you why we encounter a problem here. The second class starts at 105 and it stops at 144. So 104. Then here, suppose you have 105, and then it stops at 144. The same length here, 144. Okay, and the height of this bar is going to be 9, am I right? So you're going to say that, hey, my bar has height 9. There is an issue here. If you continue this, the graph is not going to be a histogram. The graph is going to be a bar chart. So if we continue this way, we get a bar chart, not a histogram. In a histogram, there is no gap between bars. In a histogram, we don't have any gaps. All of those bars are attached together. So what's the solution? What's the remedy for that? Okay. In statistics, what they do, they say, well, let us shift these bars half a unit to the left, half a unit to the right. So I'm trying to stretch these bars to the left, to the right, so they overlap at a number which is not part of the data collection. So forget about this. You're going to shift these graphs, shift these bars. How? Well, the difference between these two numbers is 1. 1 divided by 2 is half a unit. So I'm going to take this and shift it half a unit here, and I'm going to use the same 10, the same 5, and this guy is going to go up the 9, and this guy is 104.5. And shifting this guy a little bit to the left gives you 64.5. So 64.5. And this is going to be right here. This is your first bar. And this guy shifts a little bit to the right, 144.5. Just a little bit here. So they have the same base, and you're going to continue the same process. For the next class, it's going to stop at 184.5. 184.5 with the same height as before. I'm going to continue this. And then you're going to have 224.5 with height 4. Okay. And the next one is going to stop at 264.5. 264.5 with height 2. And then you have one. Just one, okay. Need to move this a little bit up to get this guy here. At the end. .304.5, and so on. Okay, so you have your histogram. For a histogram, you cannot have any gaps between these bars. Otherwise, you call it a bar chart. We use bar chart for categorical data. We use a histogram for numerical data. So if there are gaps in between, it's not acceptable as representative for numerical data. That's why we have to make a little bit of shift. We're going to stretch each of these graphs, half a unit to the left, half a unit to the right. So they are intersecting at these boundary points.